4.1, multiplication of fractions. So multiplication of fractions is nice. It's actually not too bad. It's just kind of straight multiplication with the idea that we'll need to simplify the fraction in the end. So that's why in this rule right here, it's showing that where you take your two numerators, it's just straight multiplication there of the numerators, and then the denominators, you're just going to take those and multiply them. And again, we're using letters here, but these should be, or they will be, numbers in this classwork and assignment. But again, don't overcomplicate this. It's just multiply your numerators together, multiply your denominators, simplify in the end. Now, you do not need common denominators to multiply fractions. You're going to need to remember this once we get into addition and subtraction. It is not required to have common denominators when we multiply these fractions. All right, so for this example, again, we're just looking at the two numerators, 3 and 7, and the two denominators, 4 and 8, and we're multiplying those with each other respectively. So on this first one, I would say let's go ahead and make this a full fraction, and I would multiply the 3 and the 7. Let's go ahead and multiply those out. And I'm going to stick with just the numerator for now, and then we'll see if something can be simplified after that. So 3 times 7 is 21. So see how I've taken my numerator. I was just focusing on the two numerators, and then once I've simplified it down into one individual value, no more operations here, then I personally kind of move to the denominator. So for those of you that are starting with the denominator, that's okay. You can do that. I just prefer usually to start with the numerators. So now with the denominators, right? We got denominators of 4 and 8. Let's go ahead and multiply those two together. 4 times 8 is 32. And then once again, we'd be looking to simplify this. So that's 21 over 32. So we should look and see first if usually the big number, is the bigger number a multiple of the first number? Because if it is, then that's usually an easy calculation. But 32 is not a multiple of 21. Okay, that's good. Next up, we would go through some divisibility rules, or you could, of course, change these into their prime factors, which we may do. But let's start with 21. I'd say, well, it only has factors of 3 and 7, just like we've shown with our multiplication back here in red. Well, 32 is not divisible by 3 or 7, which means that it cannot be simplified by either of these factors, which also indicates that this is complete. Okay, now again, if I went to my prime factorization, though, between 21 and 32, I'd say, well, 21 splits up, we already know, between 3 and 7. And the prime factorization will show that the numerator does not have any common factors to create a phantom 1 with in the denominator. So the 32, this is going to break up. You know what? I'm going to make this, I don't know, 4 and 8, like this, right? 4 splits up into 2 and 2. And then the 8, need a little bit smaller, but that's going to split up, we'll say, into 2 and 4. And then the 4 would split up once again into 2 and 2. So you see that 32 is really just a bunch of 2's being multiplied. So we got 1, 2, 3, 4, 5 of those 2's. But again, none of these factors match in the numerator and denominator in order to create a phantom 1. Yeah, you could say, well, there's a bunch of 2's that match. That's true. But you're not going to get any phantom 1's out of multiplication. So that just confirms that our original answer there, 21 over 32, is correct. So here's our first example. And again, just if I went off that rule that we just saw, we're going to take the two numerators here, which are 1 and 4, and we're going to multiply those two numerators. Of course, if we found what that equaled, 1 times 4 is 4. And then the two denominators, 3 and 7, well, we need to multiply those as well. 3 times 7 is 21. So we get 4 over 21. And now the next thing we should do is to see if these can be simplified. And by simplify, of course, that usually means that we're going to scale these down. In the last section, we did a lot of scaling up by multiplying numerators and denominators by the same thing. When we scale down, that means we're going to be dividing the numerator and denominator by the same thing, but they need to be divisible by the same thing. And in this case, there's a couple ways to look at this with these two numbers right here, okay? Especially with division. And you could go through the division rules, but you could just say, well, first off, I would look and see, well, is the denominator or numerator, or either of these multiples of each other, and no. I would have to specifically look at 21 because it's bigger, and 21 is not a multiple of 4. Well, 4 is a small enough number to kind of look at some of the divisibility rules. So 4 we would say it's divisible by 2, but 21 is not because of the 1 in the tens place value. So just going through those two parts right there, we could say, well, this is not, it couldn't be further simplified. Now the other way to do it, of course, is to take your 4 and your 21 and split it up into its prime factorization. So 4 would split up into 2 and 2. That's its prime factors, 2 times 2. And then 21 splits up into 2 other prime factors of 3 and 7. So remember, if you're going to simplify a fraction using prime factorization like this, you can, but you need matching values in the numerator and denominator to create a phantom 1. And then if there is anything left after you make that phantom 1, then you need to multiply those values. All right, so on this one, we should be able to simplify these. Now, I'm going to show them different, and there's, of course, a few different ways to do this, but one way is to just kind of make a full fraction line like this, and then say, well, look, I'm going to multiply my numerator and denominator, which we can do. So in the numerator, I've got 15 times 2. 5 times 2 is 10, carry the 1. 2 times 1 is 2, but plus the 1 there is 30. So that is my new numerator right there is 30. In the denominator, I have 2 times 15. Now, I'm going to set it up stacked like this, but you'll see you'll get the same answer on this one, which is 30. Now, at this point, you should look at this and say, well, that really would read, it's the same thing as taking your numerator and dividing it by your denominator. Numerator is your dividend, denominator is your divisor, and we know that anything divided by itself is 1. Now, I'm not going to make that a phantom 1, of course, because I need to show that. I would need to show that in the homework. But the last thing that we said with these fractions, you should be looking to simplify. And if you ever can change values into just whole numbers like this, do it. Okay? Yep. So 30 divided by 30 right here. Also, anything divided by itself is 1. Now, when multiplying fractions, it's a very common strategy to use cross simplification while you're doing the multiplication. And that would start back here when you have the two fractions that are being multiplied instead of like we did in that last problem where we made it one full fraction like this. It's possible to look at any values that could be simplified together, but they just need to be within the numerator and denominator, okay? So like in this one right here where we see like this b here in the numerator, this b in the denominator, they do not have to be part of that same fraction. And then what happens is we kind of cross those out as phantom 1, like the two together become phantom 1s. And yeah, this is one way to do it, but again, it wouldn't matter where they are in the numerator and denominators. For example, in the second one, the a here is in the numerator first, and then the denominator second. So that's not going to matter. Again, if you see something that can be simplified that way, then feel free to do it. Now, another way to use cross simplification is also to combine it with some prime factorization of the numerators and denominators. So you may have to do it like 4 times, and that's okay. It may take a little bit more time, so you may choose to multiply the numbers first anyways. But you'll see it's not going to matter. And sometimes working with the smaller numbers before you multiply, it can help. Now, we just barely did this one, but what we're going to do is we're going to do this using the cross simplification. All right, so this is a nice example of where we're going to use cross simplification when we're multiplying the fractions. And again, this is only true that we should only be using this, especially right now, when we're multiplying the fractions. We would not use it for addition of fractions or subtraction of fractions. We can with division, but there's just one thing we would need to do when we're dividing the fractions. And we'll get into that in a different lesson, but for now, again, we're just focusing on multiplication. But what do I notice? I see if I would just look for any direct matches at the beginning, and yeah, there's a 15 and 15 right there. Now, I am going to cross these out, but remember, when I cross these out, it really creates a phantom 1. And then I would go to, well, yeah, see these two matches? Well, not two matches, but the 2's that match. Again, I would cross these out, and that would create a phantom 1. Now, what we've done is we've crossed out everything. Now, if you went back far enough, a lot of times when we say cancel out, some students think, well, that means zeros. No, that's not true, and that's why I try not to use this terminology of canceling out. Again, it's more that what we've done is we've created phantom 1s. So, well, really what you have is what would have been the green phantom 1 and then the orange phantom 1. And again, this is more work than you'd ever need to show, but of course, a phantom 1 times a phantom 1 is still just 1. Anything times 1 is itself, including 1 itself. But this is our actual final answer on this 1, 1. All right, here's a new example, and yes, this one will lend itself to some cross simplification. It won't be quite as many times as that last example, but and again, these ones are indirect. So just like we did on the last one, I would look for any matches in the numerator and denominator for both fractions, or sometimes there can be 3 or 4 fractions. It doesn't matter. But on this one, I would notice that there are no direct matches in the numerator and denominator. Okay, so this one I'm actually going to do it twice, just so you can see kind of the 2 different methods on this. All right, and we still are multiplying these, but let's start with some cross simplification. And remember, if you don't like cross simplification, it is not required that you use it. You can always use the same method that we use in those first 3 problems. Okay, where it's just direct multiplication. You say, well, I know 1 times 4 is 4, 8 times 5 is 40, and then work from there, and that's fine. But do understand that whether you simplify this now or later, it will require simplification. So right now we're just kind of doing the simplification in the beginning, whereas the first 3 examples we did in this section, it's just doing the simplification at the very end. That's it. So for this one, I'd say, well, let's look at any common factors that exist with the numerator and denominator. I don't see any, but I do see the 4 and 8 right here. I don't really see, like the 1 here, okay? Everything's a multiple of 1, so I can't really simplify that, though, because it's just kind of the identity property. So 1s, they just kind of essentially stay there, okay? The 5 as well, I'm looking at the 1 and 4 in the numerators, but the 5 doesn't share any common factors with 1 or 4, but 4 and 8 do. In fact, 8 and 4 are both divisible in 2 different ways. Some of you would notice in the beginning the 4 and 8 are both divisible by 2, right? So you'd say, well, I'll take 4 divided by 2 and the 8 divided by 2, and that would change then. It would change the 2 fractions into these new fractions. So the 1 and 5, we didn't even operate on those yet. We will, but not yet. But the 8 divided by 2 in the denominator is a 4 denominator now, and the 4 in the numerator here was divided by 2, which makes it now a 2. See that? And it's now then, that is cross-simplified. It was taken across and then simplified. Of course, you could just directly simplify. Don't get that confused. It is possible to just simplify a fraction. And that may be something you'll notice as you get more experience, but it generally does take a little bit more experience to see that in the beginning. Now you could say, well, I did my cross simplification. I'm going to multiply my numerators and denominators and then find my answer, and that'd be fine. Some of you would say, well, I can further cross simplify this, all right? I know the 4 and 2 are both still divisible by 2, which is going to give me even new values for these 2, 1 denominator, 1 of the numerators there. So 4 divided by 2 in the denominator, that's 2. And in the numerator, 2 divided by 2 is 1. All right, so this created the fractions that are now much more simplified. And at this point, I don't see anything that can be cross-simplified. So what I would do then is I would essentially go back and I'd say, hey, let's go ahead and multiply our numerators and denominators here. So I'm going to show this step, although it wouldn't necessarily be required that you show this particular step the way that I'm doing. All right? So I'd say the two numerators, I got 1 and 1. And the two denominators of 2 and 5, I just need to multiply those out. And so my new numerator, 1 times 1 is 1. My new denominator, 2 times 5 is 10. And that would be my answer right there. Now, if you wanted to, you could have went back to the beginning, actually, and you could have said, well, look at the 8 and the 4 right there. What I'm going to do is I'm going to take the 8 and 4. I know both of those, instead of dividing by 2, what we did 2 times in that first part of the example, you could have said, well, I'm going to take the 8 and the 4. I know both of them are divisible by 4. And what you end up with is just a faster way to get to where we ended up with on this first method right here. Right? It's just going to give us what we have here in orange. So yeah, we didn't really touch the 1 and 5 right there. But we did do 8 divided by 4, which is 2, and then 4 divided by 4, which is 1 there in the numerator. So see how this, what I have shown right here in blue, it matches what we had there in orange. So yeah, you're just going to end up with the same exact answer that we have up there in the top right. Now another way to do this, and it's related, but it's still slightly different, is to just take the factors, or the numerators and denominators, and then split them up into their prime factors. So it would say, well, 1, that's already, it's not prime, it's not composite either, it's just 1. It's the identity. And same with 5. 5 is already prime, so I can't really split it up into prime factors. It's just going to stay that way. So if you end up with primes, just keep them there. But the 8 and 4, right? I'm going to start with the 8 here in purple. This 8, I know I can split it up between 4 and 2, which we've done already, and then the 4 splits up into 2 and 2. So the 8, what I can do is I can write it as a product of its prime factors, which in this case is just 3 2's being multiplied together. And then the 4 also could be split up into just 2 and 2. So the 4 I will write as a product of its prime factors, which is just 2 and 2. And then, and there's a couple ways to do this, all right? You can just start matching anything that matches in the numerator and denominator, start crossing things out. Some students like to make this big fraction like this. It doesn't really matter how you do it, as long as you understand that we can cross-simplify at this point. So I'll keep the line there just because I've drawn it, and yeah, it is multiplication between these. And yes, I have a green 2 here that matches that purple 2. Again, it's not that they're canceled out, it's that they've been crossed out as phantom 1s. And then this 2 as well can be crossed out with this 2 here. Well then, anything that remains is what you would multiply. So in the numerator, I've only got this 1. Of course, you could say you got these other 2 phantom 1s, but I'm just going to keep that 1. And then in the denominator, we've got this 2 times this 5, which is 10. And then once again, I'm just pointing out that, see how it's the same exact answer that we got in the beginning? So it really, again, it just comes down to preference. These two are pretty much the same method. It's just you are welcome to divide by different things or simplify the values by different values, okay? So you could say, well, divide by 2, then divide by 2, which is essentially the same as dividing by 4. And let's say that you didn't know that you needed, again, I'm pointing this out, but if you didn't know that you needed to or could further simplify at this point, it wouldn't matter. You would have ended up with 2/20ths and then had to simplify that. Again, you would have ended up with the same fully simplified answer. But it's crucial that you do end up with the same answer, that it should be fully simplified. And then, of course, our second method was just finding the prime factorization of the values, any of the values that can be changed into a result of prime factors. You can do that and then multiply, and then you'll get the same answer. As long as, again, you just cross out as phantom 1s anything that matches in the numerator and the denominator. So on this example, I'm not going to do as much work on this, but I will do it two different ways again. I'm just going to show the simplification or the cross simplification in a different way, but it'll be similar to the first two ways that we did on that last problem. So one way that students end up doing this, and this, I think it does take a lot of experience to get to this point, but I'm pointing it out because it is a little bit faster, and it may make things a little bit more convenient for you, but the students may notice that either one of two things right here, just to begin with, okay? And again, the first thing I would see is that I don't have any matches in numerators and denominators, but what I do see, just like some students may see, is that I notice the 3 and 9 are related. Some of you notice that the 2 and 8 are related. So this means I can actually cross-simplify in both ways on this. So that means that for me, since I saw the 3 and 9 first, although you didn't have to, again, and this is the way that, again, with some experience, you'll do it like this. So you say, well, I know the 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And then you'd move on to the 2 and 8. 2 and 8 are both divisible by each other, and I am color coding this so we know where and with what other numbers they were simplified with. But both of those are divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And then it's at this point that we would perform the multiplication to give us our new numerators and denominators. And yes, this will be fully simplified. This is as much as we can simplify this. So I'd say, well, 3 times 4 equals 12. That's my new denominator. Why did I do the denominator? I don't know. I just wanted to start there, I guess. I saw that first. And then the 1 times 1 in the numerator is a new numerator of 1. Okay? Now that is fast, and I didn't show as much work. Of course, you're welcome to show the work in there. Again, with, for example, the 9 and the 3 in blue. Right? You'd say, well, 3 divided by 3, and then 9 divided by 3. That's what the work that we did on that one. And then the 2, it was divided by 2, and the 4 also, it was divided by 2. So do remember, though, and don't feel bad about this. It's like, I don't really get how they did that in their, and how they do it so fast. Again, that just comes with some experience. Sometimes it's a lot of experience. It depends on the student. So if you feel the need to show this work in here, do it, all right? In fact, if you need to bring or need to have colored pencils or pens with you so that you can keep track of it pretty much the same way that I'm doing on this, feel free to do that, because we just want you to do whatever is necessary to help you out. And if it is helping you to see the colors, then yeah, I would highly recommend getting your own set of colored pencils, pens, markers, whatever it is that is most available to you. Now that's essentially, I guess, it's an advanced form of cross simplification. But I'm going to do the second method using prime factors. Okay. Now we see the 2 and the 3 in the numerators. Those are already prime, so I'm just going to keep them prime. But the 9 and 8 can be further factored on these. So I'm going to start with the 9 first. I would know that 9 could be factored into 3 and 3, both of which are prime. So I'm going to put those 3's there. That's 3 times 3. Of course, it's the product, so it's multiplication. And then the 8, we've already done that, but I'll do it again. It's going to split up between 4 and 2. 4 will split up into 2 and 2 again. Now, we've talked about this already before, but if you had the 2 here and the 4 here, it's not going to change what the prime factors are, okay? But I need to put those down. It was 2, 2, and 2, and since they are prime factors, factor indicates multiplication. So we have that down, and then I would be looking for any of these factors that match in the numerator and denominator. And yes, we do have some. I got this 2 here. I'm going to match it with this one. And yeah, I tend to do it when I'm doing it formally with any values far to the left. Some students will say, I'm going to cross out this 2. Okay, that's fine. It's not going to change the answer. Or you could cross it out with this one. That's fine too. And then, in addition to that, I see a 3 here that can match with this 3. Okay, so again, those all become phantom 1s. And then, well, what are we left with? In the numerator, I don't have anything left except for what was remaining from the 2 and 3, which were crossed out, which means they were phantom 1s. So I'm going to show that one there. And then in the denominator, I have 3 times 2 times 2, which you can do. So 3 times 2 is 6, and then that times 2 is 12. And yep, we end up with the same exact answer here that we got up here. And again, I am pointing out that it's the same answer no matter which method you choose. But I'll reemphasize this as well. If one of these two methods is working better for you, do it, okay? Or if, showing the cross simplification like we were doing here with the division or whatever, it doesn't matter. Just do whichever works best for you. That's the main point right here. Find something that really works for you and then roll with it. I didn't say you had to like it, by the way. That's a different story. All right, here's another example. We're going to multiply these out. And then on this one, actually, I'm not going to worry about the prime factorization. That's a very rare method to be used by students. So let's look at this one by simplifying and cross-simplifying these without the prime factorization. Now again, the first thing that I would do is I would check to see if there's any matches in the numerators and denominators, just to start out with, and I don't see any. Right? No 7 matches in the denominator, no 5 matches in the denominator, no 10 matches in the numerator, and no 21 matches in the numerator either. But what I do notice, and this is the first one I noticed, was the 7 and 21. Some of you may have been easier to notice the 5 and 10, and that works as well. But I know the 7 and 21, they're actually both divisible by 7. So what I can do is I can say, well, I'm going to take 7 and divide it by 7. And 21, I can divide it by 7, which is going to give me new values to put into these two places of this multiplication problem. So in the top left, that's 7 times 7, which is 1. And then right here, bottom right, I would say, is 21 divided by 7 is 3. So by simplifying the 7 and the 21, it's almost like we are treating these as their own fractions. And again, that's because we can essentially just make it its own large fraction with multiplication shown in the numerator and denominator. So that's why this works. It's like saying, well, you could have just made it 1/3. Yeah, that's true. Okay. So the 5 and 10 there, I see both of those are divisible by 5. Because 10 is a straight multiple of 5, just like 21 was a straight multiple of 7. So on the top right, I have 5 divided by 5, which is 1. And then in the bottom left, in the denominator, 10 divided by 5, which is 2. So let's go and multiply these out. And I got 1 times 1 in the numerator. And in the denominator, I have 2 times 3 there, which will create a new numerator and denominator. 1 times 1 is 1. 2 times 3 is 6. So it looks like our final fraction here is 1/6. Well, I did decide to do this a second way on this, and I hope that's okay. Some of you may not need this, but instead of using cross simplification on this, I'm just going to do it essentially the old-fashioned way, which is the way we did the first 3 examples, right? So I would say on this one, let's just go ahead and make it one big fraction right here, and let's multiply our two numerators, 7 and 5, which is 35. That would be my new numerator. And in my denominator, then I would take 10 and multiply it by 21. So it's multiplication of 10, so I would take the 21, just tack a 0 onto it. Now you can check, but 35 and 210, well, 210 is not a multiple of 35, so it's not a direct calculation on this one. And you could say, well, I'm going to take the 35 and 210 and change those into their prime factors, and that would be fine. But you could use divisibility rules. I would say, look on this one. We got a 5 and a 0 in the ones place value, which means that both of these numbers are actually divisible by 5, at least to start out with. Probably even more than that, but let's find out. So 35 divided by 5, that would be 7 in the numerator. And then the denominator, 210 divided by 5. Let's find out what that is. Since we're not able to use calculators, I'll use long division. 5 won't go into 2, but it will go into 21 4 times. 4 times 5 is 20. Subtract that, we got 1 left over. Drop the 0 to make that 10. 5 goes into 10 2 times. 2 times 5 is 10. Yep, you got 0 remaining, which is what we should have. So 210 divided by 5 ends up being 42. But I see that 42 then is a multiple of 7, which means then that I could further simplify this by dividing both the numerator and denominator by 7. And again, since we are looking for the simplest form or the most simplified or lowest terms form of this equation, this fraction, yeah, we're using a lot of division on this. So 7 divided by 7 is 1. 42 divided by 7 is 6. And you see we end up with the same exact answer that we had up here, the in green there, the 1/6. All right, multiplying with whole numbers, just so you understand, whole numbers are actually fractions. They just don't usually show the fractional part of it, okay? And this is how this works is whenever you see a number standing by itself and you need, just in case you needed to apply some operations with fractions, you're welcome to show that as something over 1 like this. Okay, so, and I think we've seen this slide before. If you ever see something by itself, it's possible just to write it as something, as the same thing divided by 1, but as a fraction, so it's over 1. But it's like we've seen before, anything divided by 1 is itself. So again, it's just like saying, well, instead of saying instead of saying I want the whole number by itself, I want to see it as a fraction over 1. All right. So this means, let's see if we can emphasize this. So if I looked at a number such as 2, it is possible to write it as 2 over 1. Or if you saw a number like 5, it could be big as well, like, I don't know, 52. You could, if you wanted to, write it as 52 over 1. Okay? And again, this part right here is just saying you could work it backwards. If you had something divided by 1, you can change it back into just 52 if that's convenient for you. All right? But it is more about convenience. And where we are multiplying these fractions, yeah, it may be more convenient to see whole numbers as fractions like this. All right, so let's multiply these, and you'll see what happens hopefully fairly quickly. And yes, I do think that cross simplification will come in handy on this one, but see this, this 5 right here is just standing alone there. Well, I could make it a fraction as 5 over 1. See that? Well, then I have these 5's in my numerators, and I could say, well, that 5 can be divided by 5, and same with this one, which is going to make new fractions. So I'd have over 1, but now it's 5 divided by 5 is that numerator, 1. And then the other fraction, I have the 1 in the numerator already, but in the denominator, 5 divided by 5 is 1 again. And then, and this is, I'm going to show this a little different than we've done it in the past, but right here I'd say take your numerators and multiply them. 1 times 1 is 1 all over. The denominator, 1 times 1 again, which is 1. And I'm not showing the operation with these arrows because it's already shown right here in the problem already. So the last thing I would do on this one is say, well, look, I've got 1 divided by 1, and it's nice, but what I would really like is to simplify that further. And I believe this is the case that it wants it on the assignment, but to consider this fully simplified, yeah, you would have to actually make it just one individual value there, because anything divided by itself is 1, including the 1. So this ends up being 1. Or we can multiply these. 30 times 37 over 54. Yep, we can change that 30 into 30 over 1. Then I'd look and see, well, you know what, I'll use prime factorization. I know it's not as common, and perhaps some of you hate it, but I think it may be helpful on this one. By the way, we don't need to worry about the 1 or the 37. It is also prime. But the 30 we do need to worry about. Okay, so that's my numerator of this first fraction. It's going to split up, I'll say, into 5 and 6. 5 is prime. 6 though splits up into 2 and 3, both of which are prime. So there I've got 5 times 2 times 3. That's my numerator. And then the 54 in that denominator there, I'm going to split this up into, I'll say 6 and 9. So 6 splits up into 2 and 3, both of which are prime, and then 9 splits up into 3 and 3. So that would end up being 2 times 3 times 3 times 3 in that denominator, Yeah, we're just looking for anything that can be, that has any matches in the numerators and denominators. So what do we get? I got these 2 that match there, so I'll cross those out. Again, that's a phantom 1. And this 3 right here can make a phantom 1 with that purple 3 there. Well, now I can just multiply straight across. And I'm going to start with the denominator just because it's the easiest. 1 times 3 times 3. 1 times 3 is 3 right here, but then multiply by this 3 and you get 9. So that's my new denominator, rather. Yeah, this will be fully simplified even when it finishes. And I'm going to keep this as an improper fraction once it finishes. But on the numerator, I've got a little bit more multiplication to do. I got 37 multiplied by that red 5 right there. So I'll multiply these out, and that will be my new numerator. 5 times 7 is 35. Carry the 3. 5 times 3 is 15, but plus that 3 there that was carried, it makes that 18. So my final numerator here is 185. And yep, since we use prime factorization on this, we're not actually able to simplify this any further. Now, did you have to use this method? No, you did not. And if you prefer to use any of the other methods that we've seen, feel free to do that. But your answer needs to be the same. All right, this one's just a little bit different because the whole number now is the second factor instead of the first one. Still not a problem. Yeah, we can still make that an 8 over 1 right there. Now, whichever method you choose, I'm actually going to start with I'm going to finish with the same method that we started with. So on this one, I'd say, well, look, in my numerator, and I'll rewrite it, though. My numerator, I would have then 5 times 8. And again, just sticking with the numerator so I can finish that off. 5 times 8 is 40. And then in the denominator would have been 6 times the 1 there. And so 6 times 1 is 6. And yeah, both of these, the 40 and the 6, have even numbers in the ones place value. So I know these two are both divisible by 2. And while 6 is pretty quickly divisible by 2, some of you may need to do some long division for 40 divided by 2, though. Whether you do or not, I'm doing it. So 2 will go into 4 2 times. 2 times 2 is 4. So subtract the 4 there. That zeroes out the 4s. Now the 0 from the ones place value. 2 goes into 0 exactly 2 times. So that's just our remainder of 0, which is what we want. And the quotient there being 20 is going to be our numerator. And then just a final check here. Can 20 be divisible by 3? No, it is not, because 3 is prime. That's the only number we need to check with 20 right there. And since it's not, that means we have fully simplified this fraction.